All right, good morning, everyone, and welcome to Water Around the World, Local Problems, Global Solutions. My name is Elena Harkness. I'm the Executive Director of Current, and I'm very pleased to welcome you to the next in this series of global partnerships conversations around the best ways to address the water challenges we are facing, both here in Chicago, where Current's headquartered, but also around the globe. Today, I'm really excited to welcome our partners from the Consulate General of Denmark's The Trade Council on a really important topic, wastewater asset management, smart choices. A few logistics in case this is your first event with us. Please submit your questions in the Q&A tab and any general comments in the chat. We really like this to be interactive. We have a terrific lineup of speakers and innovators today. So please, if you have burning questions or thoughts or just comments to share, please use both of those freely. This will be recorded, and like all of Current's events, will be shared on our event page and also on our YouTube channel. So subscribe to that, check out, there's lots of great content there. We'll also send the video to you after the event if you've registered. Just a really quick run through our agenda. This is a slightly longer program today because we do have a lineup of speakers that's a little bit bigger than usual, which is terrific. So I'll give a few brief remarks about Current and then introduce our partners at the Trade Council of North America for the Consulate General of Denmark in Chicago. We'll have a bit of an overview on the problem, and I'm really excited to be welcoming our colleague from the Metropolitan Water Reclamation District of Greater Chicago, Lou Storino, who's the principal civil engineer, and he'll be giving us a bit of a sense of the overview of the problem. And then we're going to have our lineup of terrific presentations about solutions of what stormwater and wastewater utilities can do to better manage these challenges. We'll build in Q&A throughout and try to get you out of here at 30 minutes after 11, and that's our agenda for the day. So just a bit of an overview about Current. So Current is Chicago's water innovation hub. And if you've joined our events before, you know that one of the things we try to do is build global partnerships to support better solutions to Chicago's water challenges. We are here because we can all agree that everyone, wherever we are in the world, whether we're in Chicago or Denmark or anywhere in between, we all need more healthy water to drink and less flood water in our basements. These are challenges that are affecting us here in Chicago today. Next slide, please, George. But also, just in the last several days, even in the last 12 hours, there have been multiple headlines about how critical our infrastructure is challenged by the changing fluctuations of climate change, by increasing stormwater, increasing rainfall events. There was a very large, prominent article on Chicago's climate future and why climate uncertainty is affecting even the Great Lakes. We're not even a coastal city in the sense of being located on an ocean, but we are still facing tremendous uncertainty, unpredictability caused by climate change. So we've had LA beaches were just closed with a sewage discharge overflow, and just now I've gotten an alert about the incredible flooding that's going on in Western Europe and sadly affecting millions of people there. So this is a critical challenge. It's on our doorstep now. Next slide, please, George. And what Current is doing to address that is really trying to build the collaborative, creative partnerships that will help innovation come to market and come to scale faster. So our problem statement is that we're not rallying fast enough behind some of these new ideas and technologies that will protect our health, our environment, our water. So we know that innovation takes partnerships, and often the problems we're trying to solve are too large and complicated for any of us to tackle alone. So Current exists to create the kinds of collaborations among industry, government, nonprofits, businesses, researchers, everyone trying to take more rational risks to try out new solutions and bring them to market faster. So that's why we exist, that's why we're here. And I'm really excited about the Water Around the World series because it highlights the importance of our trade relationships and the innovation partnerships that we're building across borders. So we've been very thrilled to have our partners from Denmark here, leaders on so many different aspects of water innovation. And I am going to now turn it over to our colleague Christian Vfds, who is the commercial advisor at the Consulate General of Denmark right here in Chicago. And he's going to give a bit of an overview about this series and the partnership we have. So Christian, turn it over to you.
Perfect. And thank you for the introduction, Elena. And first of all, thank you for participating in this event, everybody. It's nice to see that so many people are interested in participating in a webinar like this. As Elena just said, my name is Christian Ivy Eugene. I'm working out of Chicago as a commercial advisor at the Consul General of Denmark. I'm a part of the team working for the Danish Water Technology Alliance, which is an alliance created to share know-how across the borders between Danish and American utilities about new innovations, ideas, solutions that could be relevant also in an American utility context. This is something we do through partnerships with associations like Current. We are sponsoring this event series to create focus on some of the relevant topics that have developed and innovated the Danish water sector during the years. And we hope that some of these stories can inspire and maybe even open up for new progressive collaborations between some of our partners and you guys to help you solve some of the problems that are happening here in the States. If you guys are interested in talking and discussing further after the webinar on any of the topics related to today's discussions, I would just be interested in an informal walk and talk with one of our technical advisors at one of your facilities, then please feel free to reach out afterwards. We are here, we are present all over America and Texas, Cali, and the Midwest, and would like to continue the dialogue with you guys afterwards. So thank you, and once again, welcome to today's webinar.
Thanks so much, Christian. We're so fortunate to have you here in Chicago as a partner and collaborator, and thank you for all you're doing on behalf of the Danish sector, but also the water industry at large. We appreciate you so much. Now I'm really excited to turn it over to another terrific colleague here in Chicago, Lou Storino, who's the principal civil engineer at the Metropolitan Water Reclamation District of Greater Chicago. He's going to give us a bit of context setting about the challenges that our storm and wastewater utilities are facing today. So Lou, all yours.
Before we begin, I just want to state that the Metropolitan Water Reclamation District of Greater Chicago does not endorse any products, manufacturers, or contractors. The district was asked to set the stage for today's talk, and I will begin with a brief historical presentation, which I hope you will enjoy. So how did we get here? In 1852, the Illinois legislature empowered sewage commissioners to install sewers in the most densely settled areas of Chicago, and the new sewers were laid at the level necessary to accomplish gravity flow. Earth was then packed around the sewers and new streets were constructed above the sewers. So this graphic here shows the view of an entire block of brick and stone buildings in Chicago on Lake Street between Clark and LaSalle streets, while being raised to a new grade of 4 feet so that the sewers could be placed and flowed by gravity. So note of thanks to the Chicago Historical Society for this photo, and we can go on to the next slide. So by 1906, the district began construction of its intercepting sewer system, sometimes referred to as the trunk sewers. These sewers serve to collect wastewater from the local municipality sewer system and today take water to one of 7 water reclamation facilities. This photo shows the construction of our Calumet sewer on November 20, 1916. And if you take a close look inside the sewer, you'll notice that some workers are taking a break after a concrete pour. And go on to the next slide. So material was typically hauled in and out of sewers under construction by mule in 1928. If we can go on to the next slide. And if the sewers were larger in size, we actually show here battery operated rail for larger sewers to remove the construction debris. And this slide takes us back to 1929. On to the next slide. Due to the nature of the soil, much of which was Chicago blue clay, the procedure required excavation by hand and the installation of ground support. The distance was only what could be mined out and lined with concrete within 24 hours. This involved setting reinforcement, placing the concrete invert, and pouring the walls and arch. A few days later, grouting began to fill any voids, and finally a thin concrete finish layer was placed on the invert. And many of these sewers are still in useful service today. Mm-hmm. So sewer asset management is becoming more and more important in recent years due to economic considerations, since infrastructure maintenance and rehabilitation represent major investments in sewer systems. Next slide. As the water reclamation facilities were built in the area in the 1930s, intermediary lift stations were built along the collection system to lift wastewater, in some cases upwards of 40 feet or more, so that the wastewater could continue to flow by gravity to these new treatment plants. So this photo is showing the Upper Des Plaines pumping station in River Forest, Illinois, designed to blend in with the surrounding neighborhood and placed in service in 1938, and it continues to operate today. The station houses 3 centrifugal pumps with a 38 total dynamic head and 350 horsepower motors. So most water and wastewater facilities in the US are designed and built with large pumps, drives, motors, and other equipment that operate 24 hours a day. Energy costs can represent 25 to 30% of this total operation cost for wastewater and water utilities. Operational improvements allow for some of the greatest opportunities to improve energy efficiency at water and wastewater facilities. Energy efficiency can help lower the costs for water and wastewater utilities while improving the performance and service. On to the next slide. So these sewer systems that we're showing here in older communities in the Chicago area and really across the United States were built as combined sewers, carrying both sewage and stormwater runoff. Newer communities are built with separate sanitary and storm sewers. As these interceptors were placed into service, connection to the local waterways were left in place and structures built to allow for combined sewer overflow. So during storm events, wet weather flow from local combined sewer systems is diverted into the district's tunnel system, also known as TARP. And when the capacity of TARP is reached, combined sewage may discharge into local waterways. And this is something that we really want to try and minimize.
Mm-hmm.
We go on to the next slide. We also have odors emanating from sewers that can be an issue on 2 fronts. One, it can be a public nuisance and can be indicative of high hydrogen sulfide, which may prematurely degrade the sewer system. This screenshot illustrates our district's tracking system. It's a GIS-based odor complaint tracking system. And the small circles represent catch basins in the collection system, while the large brown circles represent odor complaints. There's a circle that I have highlighted that has the number 3 in it. And this signifies that in this particular location, we have seen 3 odor complaints since 2014. And these odor complaints are investigated to determine the cause. Necessary remedy measures that are taken can include charcoal filters in the catch basin, cleaning the sewer system, or adding a deodorizing agent to the catch basin. If odors are persistent, long-term other measures are available to remedy the cause, such as introducing chemicals upstream. And finally, on to our last slide. You know, the innovators at today's webinar will paint a picture of how the future could look for sewer asset managers and showcase some of the examples that have successfully helped Danish sewer asset managers avoid cost increases and extend the lifetime of these assets. The 4 key focus areas for today are digitalization of sewer systems and data-driven overview, predictive maintenance, pumps and efficient cleaning of the sewer system, and energy efficiency. And back to you, Elena.
Thanks so much, Lou, for painting a picture not only of the challenges, but how incredible feat it is that MWRD and others, other utilities like it, have been able to keep these incredible pieces of infrastructure up to date, moving, keeping us all safe and dry, and just really appreciate the work that you're doing. And thank you so much for teeing up the stage for the innovation ideas that we have to come. So with no further ado, I'm going to turn it over to our first presenter, Mads Varming from Danfoss, and he is going to kick us off. So Mads, please take it away.
Just a second. It probably helped I unmute. So yes, and thank you for this opportunity to talk a little bit about some of the projects we have been involved in. So next slide. Please. So, super short about who is Grundfos. Grundfos being a global company, 28,000 people, around about $7-8 billion US, all over the place. What probably could interest here is that we have one of our major factories doing drives just an hour outside of Chicago in Rockford. And else we are producing a lot of the drives for the water industry from a factory in Denmark and a sub-factory in Germany. And just flick once more. Drives, I will, variable speed drives, I will not talk too much about. That was not the intention today. I will talk more about some application we have been involved in. But I guess you all know that the benefit of drives in the water industry is basically that if you just can on a centrifugal pump can reduce the speed with around about 40% or 20%, you'll get around about 40% energy saving. It has a relevance in the sewage canalization system, but it has more relevance, of course, on the drinking water side and on the wastewater side. But it also has a relevance here. I'll come back to that. Next slide. This is, I think we saw some picture of how it's looking right now in Germany, how it was looking a little bit in US. So it's also sometimes looking in Denmark, as you can see here, where we have flooding. And even though we try to avoid it a lot. And I think also the introduction, which were done from Chicago, that there's a wish to limit the amount of stormwater overflows. That certainly is also the case in Europe. In fact, there is set up from Brussels new regulations which push the authorities that they have to find solutions so that we get less sewage overload, and at the same time, as we all know, we get more and more heavy rain. So that is quite problematic, and quite a lot of money is thrown into it. What this picture should show is an installation made in the second largest city in Denmark, where the concept is to have radars installed over the city. And the purpose of the radar is to determine how much water is we getting and for how long time. And that is connected then to a dynamic model, which will then calculate how much flow do we get different places in the city. And in the sewage canalization system, there is, of course, level meters. There's a couple of what we call software sensors. There's variable speed drives, what we at from Grunfus like a lot. But the key point is, in fact, that if you have such a model which can predict that in maybe in the southern part of the city, you know that the water or the rain will stop within the next quarter. Then you also can decide, because you are in full control, process control, that you leave some of the water out there and use the reservoirs you may have built, maybe to take water from another part of the city and fill the reservoirs up there. And in that way, in fact, utilize the capacity which is in the whole city in a much better way. And at the same time, the whole system is connected to the wastewater facility, and where there is a possible change on the wastewater possibility on wastewater treatment plants, so that it can cope with a 40% higher hydraulic load or 40% higher flow rate for 2 or 3 hours. And that means that you also can get more water through the wastewater facility. What is interesting, and what we don't have time to deep dive into all the details here today, but the interesting thing is that they were saving round about 1/3 of the total investment. So round about $30 million they were saving on doing this, which you could call digitalization. So invest in radar, invest in level meters, invest in flow meters, invest in variable speed drives, and of course the process control of it. So they were saving $30 million, which alternatively should have been invested in a lot more concrete in the ground. So this is options to consider. On top of that, what they also gain from this system is, and I think we heard that just from the US case also, that they at the same time have a full overview over where do we have water, how much water, and therefore also if there once each second year, which is designed for, should be a stormwater overflow, they immediately can warn via mobile system and a lot of other concepts. They can warn the people in the city or at the bay that they shouldn't go in the water that day. Yeah, next slide. Yeah, just go ahead. So there's 50 variable speed drive installed just in part of the city to cope with that. But basically the philosophy is that there will be a variable speed drive on every motor, which either in the network or in the reservoirs. Then coming a little bit to variable speed drives and how they can be used for more than just regulating the speed. One of the things we have introduced to the marketplace is what we call edge computing. So instead of having a cloud connection, we don't need cloud connection here. We do all the calculations down in the drive itself. And what we are able to do is, in fact, to supervise the motors, the windings on the motors. We are able to have a vibration sensor connected directly to the drive, and we can also make something we call load envelope. That basically means that the drive over time will learn how the load is at given speed, and if that load deviate either high or low, a warning can be given. As the same as you can do with vibration monitoring, that the drive itself will figure out what is the normal vibration we have in this pumping station here. And if we then have an abnormal situation, the drive will tell you that there's something potentially wrong with this application here. Yeah, next slide. The other thing which I think there was a little bit of touch on is that especially in the sewage calcination system, we all know that pumps can clog. And we also all know that there is no standard for how often they clog, because that, of course, depends on how the wastewater is. What is built in again as standard in these dedicated drive is what we call a deracking, or you could call it an anti-clogging function, which basically means that it will detect when the pump begins to clog. And then it will spin the wheel the opposite way, and in that way, in fact, clean the pump. What that means is that we typically see that you extend the maintenance interval with a factor 2 to 10. And what a lot of people forget when we talk energy is that if you accept that you have a clogging pump and you go out each second month and clean it, then you must also accept that during these 2 months, the efficiency of the pump will drop and drop and drop. Then you clean, then you got up at 100, then it drop and drop again. Now, if you let the drive instead do the work for you, then it will see to, as the white line is showing here, that you keep your efficiency up on these pumps the whole time. What we have seen is energy savings from 10 to 50%. So as I said, it depends a lot on the application. And the latest case, which is not more than two weeks ago, coming out from Asia, but it doesn't matter, was that they were used to have to take the pumps out 22 times a year. And having this installed, they are now down on 2 times, which is not necessary because it's needed, but just for regular maintenance, and a return on investment on 4.5 months. Even though a lot of people think wastewater calcination system there's not a lot to do on energy because it's gravity system and so on. Yes, there is a lot to do, and there's in fact a lot of digitalization you can put into this and really improving the system and saving a lot of money. Yes, I think that was it. Next slide. Yeah, that was it.
Great. Thanks so much, Matt. So I just had a couple of questions. So just to put this in context, if people are able to keep pumps from clogging, that's also reducing then the downstream impact of things like the combined sewer overflows that Lou mentioned, right? When we're thinking about releasing things, like just what's the correlation there?
Yeah, I don't know if I can tell you in detail, but you're of course right that if you can keep your pumps running smoothly the whole time, and basically you can, the system is designed so that you can decide if you want this anti-clogging once a day, or you want the drive to measure when it should be done. Both things is possible, but it basically means that you will have a much higher uptime on these pumps, and you'll be sure they're always running. Yeah. For a much higher degree than what you else are seeing, and that to super small money, in fact, compared to what you else see of issues here. So it's certainly something which we see spreading a lot. Let me say it that way, because it is a very simple thing to do, but it really helped also on the maintenance crew that they don't have to run out as often as we'll see. So yeah.
Audience question, why was this configured as non-cloud monitoring? Why did you choose to keep it out of the cloud?
No, I did that, and good question. The reason is that at least in Europe, I see also in Asia, and probably if I know the US market well, there is a certain reluctance to have everything connected to cloud, and especially on the process side. I know water service companies is using cloud for a lot of things, but when we get to the process sensible things, there's a little bit concern if somebody should hack in or should do anything else. And therefore, our philosophy have been that of course you can connect the drives to the cloud if you want, but you don't need to do it. So
Okay.
we have integrated all the know-how or all the calculations that's done in the drive itself. So you don't need to have a cloud connection. And
So the answer is right. So cybersecurity or sort of security and protection is
yes. And at the same time, it have proven also cost-wise to be cheaper.
Yep.
To make all the calculations down in the drive instead of have a wire up to the cloud and have to pay for that you have something operating in the cloud. Yeah.
Okay. So cost and cybersecurity. Great. There's another question. Can you show us an example of remote maintenance? I'm not sure that's possible in the time we have, but if you maybe could drop in the. I could. Also, we have a lot of application on it. If that's the question is. Yep.
So we can easily do that. But it's a question. If I should put a few words to it, then it's known and have been known for many years that you could have vibration sensors, and it could make a lot of sense to have vibration sensors on pumps.
Yep.
But it have been a little bit expensive and complicated to do. Now what we have done is that you can connect the sensor directly into the drive, and then you push one button, and then the drive do the rest of it. It make its own baselining. It figure out if there's some abnormal things. So it have got again a lot cheaper and a lot easier to work with than have seen previously. Yep.
Great. And last question: can VFDs detect wear on pumps and maybe sort of start to predict failure?
No, to be honest, not really. So we can, you can on what I call load envelope, you will, if there's a lot of wear, you'll be able to see it. But I would not say that that we really can measure how much wear you have. If you have extreme deviations, yes, we can see it. But we cannot see if you only have 1 or 2% deviations. No.
Great. Well, thank you so much, Mads. That was a terrific presentation. And we're going to go right on to our second presenter, Brendan Watson from Grunfos. So, Brendan. You're on mute, Brendan. We can't hear you. We heard you in the rehearsal before this, but having a hard time now. Can you try again?
Can you hear me now?
Yes, perfect. Thank you.
Okay, I'm sorry about that. I don't know what happened.
No problem.
It was working fine earlier. My apologies. Yeah, so hi, I'm here to talk about our remote monitoring systems for pump stations. Next slide. My name is Brendan Watson. I work for our service department here in the US as our digital service sales manager. Next slide. Now, what most people know Grunfus for is our world-class pumps. We're a global supplier, or actually the largest supplier of pumps in the world. But some things that people don't realize that we have are actually our full line of controls and system components, as well as remote monitoring systems. And some of the topics that were discussed previously with Mads kind of fall in line with our controllers that you see there on the left, which control pump stations and tell pumps when to run, but really getting into that key word, which is predictive maintenance, being able to see problems happen before they happen. And then we're going to talk a little bit about our components on the right. We're going to show some examples, but primarily what I'm going to be focused on is our remote management system. Next slide. So what is a remote monitoring system? So we have a pump station there on the left. That's could be a lift station, a stormwater station. We have our control system that talks through a cellular modem and antenna up to the cloud, and then allows a user to access their information over an internet connection, cell phone. Basically, it's an easy to implement cloud hosted system. It's typically based on a cellular connection. These systems are more prevalent now globally, which allows customers to remotely monitor their systems much easier than having to do the traditional radios, repeater towers, servers, big softwares. This is kind of an out-of-the-box system. Next slide. So our solution here at Grunfus is something we call GRM, which stands for Grunfus Remote Management. And what this is our off-the-shelf cellular monitoring solution that can monitor virtually any pumping station or system. It allows easy access to data from your stations, as well as your pumps, your controllers, but we can also work with third-party equipment. So even if you're not using a Grunfus controlling system, let's say you have an Allen Bradley or Siemens PLC system, we can still monitor and report alarming and notifications from those systems as well. And that is the final point, which is the alarming and notifications to operators and users that we send out text and email alerts. So if there's a problem at the station, the operators or the users are notified. The next slide. Okay, so what's the information that you can get off of GRM? So as I mentioned, it's cloud hosted. So once you install the equipment and you're passing data through the cloud, you have access to our servers, which is our system is hosted on our 24/7 monitored servers. And that's a screenshot that you see there is one example of a controller. That's actually a Grunfus controller. Go ahead and hit the next. And what you see down there circled is pump status information. So it's showing you information about your run times, your starts, how much current the pump is pulling, and it's all dependent on what you have at the station. But as you can see just right off the bat, you start to kind of see information that is typically monitored manually in most cases, where there's a clipboard inside the panel door that somebody will write down the information, the run times. But here's a way that you can really easily kind of look at, maybe is there something wrong here? Hit the next button. And if there is something wrong or if something's going on, you get notified, and the system will notify via text and email. And these are some examples of cleared alarms. This is actually from a customer site. And you can see in this case on June 28th, they had a mains fault, which means they lost power at the station, which coincidentally caused all those communication faults. But then you can also see they had a flow monitor out there that they lost signal to as well during that. So this notified the customer that they did not have power at the site. Hit the next button, please. Some other information that's collected, if you have a flow meter or even if you don't have a flow meter. So if you're using one of our controllers does flow calculation without the need for a flow meter. And if you're using it in conjunction with a power monitor or a VFD, as Mads talked about with Danfoss, we can pass that information into our control system. And what that gives you then is starts looking at volume, but it also starts looking at specific energy, which is really an efficiency. So there was a question about, can we determine if a pump is going down? Your specific energy is going to tell you everything about the pump. And what specific energy is how many gallons you're moving for every unit of power that you're using. So it's kind of like a miles per gallon for your car is a way to think of it. So what GRM is doing is when it's working in conjunction, especially with our controllers, we're getting you really into that predictive maintenance where we can start to see problems before they become problems. And we like to call that run to fail here in the US. A lot of municipalities, a lot of stormwater systems operate on a run to fail, where we're going to fix the issue when it happens. What we're doing with GRM is not only reporting when issues happen, but we're giving you the information so you can see deterioration on your system and fix it before it becomes a catastrophic failure. Next. Here's an example of a very basic system. So that little module you see there on the picture there is actually a Grunfus control module. And this company that we worked with, and all they wanted to do was monitor if they had a power failure, if they had a high level alarm, and they just wanted to get information on their pump running. So we put that little module inside their panel, wired in from the starters, and we started monitoring what was going on at the station. What's interesting about this, if you can hit the next button, what's circled there, we found this right off the bat, that they were noticing, they didn't have any idea this was going on. And the station, in their mind, had been running fine because the person that they were running the station for never called with an issue or anything like that. But what's interesting here is we looked at the average start duration, and this was just from running a signal from a contactor or a starter into that little black box. What we found was if you look at pump 2 is running 48 minutes average, whereas pump 1's only running 8 minutes. What we found, we went out there and actually investigated it. These were older pumps that had a manual flush valve. It had a little valve that you turned on and off, and somebody had left it on. So it was every time pump 2 was running, it was just dumping water right back in the station. So even though the station was ultimately pumping out because pump 1 would do all the work, they were wasting tons of energy. Not to mention, if there was an issue where there was a large event, they couldn't pump it out. Next button, please. Over here, when we set this up for them, or rather they actually set this up for themselves, they wanted to monitor a high-level alarm. But when these alarms come through, they go to a dispatch. They don't actually go to the operators. They could, but in this particular case, they have a dispatch operator. When the dispatch operator received these alarms, they needed to know what they needed to do about that alarm. So they get a high-level alarm. What does that mean? In their case, they actually put their own words in there. They said, send a service tech to the site. So when they had that, we can also see they had a power failure as well. Next slide. So this is an example of GRM when we hook up one of our Grunfus power monitors called the MP204. So we had a customer that was prematurely losing pumps, and they were under the impression that it was an issue with their pumps and their motors were failing. What was actually happening was an issue with the incoming utility supply. And that's something we see all over the United States, and I'm sure it's an issue globally, especially with more electric cars coming onto our grid system, power grids. It's causing voltage imbalance. And what voltage imbalance in our grids does is it causes current imbalance. And you can see here above 10% current imbalance for a short period of time on this one station. They ended up working with the power company, and they found it was actually a industrial park that was turning on machinery, and it was causing this voltage imbalance in their system. Well, it was only for a short period of time, but if you do that every single day, that current imbalance right there is cutting the life of their pump significantly. So a lot of the failures that we see when we talk about predictive maintenance, a lot of times are caused by the power. But how do we know that? We have to be able to monitor the incoming voltage and current. So, or excuse me, voltage and then current draw. That's what we can do with GRM as well. So we do this a lot for customers, and it's really interesting to hear the feedback because most customers don't realize they've had imbalanced voltage coming into their station. Next slide, please. So why GRM? We're not the only ones out there that do a cellular monitoring system. There's actually a lot of companies out there. We're very easy to install and operate. We actually own our own software and servers. So we do soup to nuts for these type of systems on our own. We don't sub anything out. It's all internal to Grunfus. Here's the big kicker. This is where we're different. We actually have two-way control with our cellular monitoring system. Most systems that are out there just monitor for high-level alarms and things like that I showed you, but we actually have the ability to manually control pumps and other equipment remotely. So from your phone, you could turn a pump off if it became an issue and you didn't want to, you had somebody that was 30 minutes or an hour away. You could change settings on a controller without having to physically go to the site and do it. We can actually do things that help eliminate spills through GRM, where we can actually shut certain in lift station applications, shut them down so they become holding tanks essentially. So that's one of the things that makes us very unique, is that we allow two-way control, not just monitoring. Next slide. So if you want to learn more information about this or other topics, really any pumping up topics, we offer, it's on our Grunfus Technical Institute, which you can do a search on or use the link there. One of the presentations that I've done on there is called Power Quality in Pumps. Is power killing your pumps? And I explain what voltage imbalance is, why it's there, and how it affects your pumps. And I explain it in layman's terms. So if you're not unfamiliar with that issue, I would recommend going to our Grundfos Technical Institute and watch that presentation, because in my opinion, it's very eye-opening, because it tends to be something we overlook a lot. Next slide, please. And that's it.
Thanks so much, Brendan. So it's so clear how much this prediction, the predictive capacity links to the ability to sort of prevent some of the catastrophic outcomes that we've heard about today in the framing. There were some questions. I think I'll just start in the place where we sort of left off with Mads, which is around cloud versus not cloud. So you all are in the cloud. How do you address some of the cybersecurity concerns about that and just accessibility there? How do you think about
Sure. So without going into all the details, because it's all Grunfus products, we maintain the security encryption. So we have encryption not only through our products, through our hardware, but out on our server side. So our servers are monitored 24/7 and secure. So from a security standpoint, the best way we like to explain it is that it's a security of that of like online banking. It's the same level of security online. And I see a question here too about, can we connect to Scada?
Yeah.
So
Well, real
no.
quick,
Oh, sorry, go ahead.
Just for those who might not know what Scada is, supervisory control and data acquisition systems. Like,
Right.
Yeah, I just want to make sure we're defining that.
Yeah, no, so Scada basically, what we're doing is we're showing you your pump station. There are softwares out there that you can buy and host yourselves at your facilities and pass the data through radio and even in some cases cellular back to that information. So we're essentially a canned Scada system. In other words, you buy our product and plug it in and it's already done. You don't have to do integration and software development. Can we connect to existing Scadas? Not today. In the future, we hope to be able to do that, but not today. We cannot push our data into an existing Scada system.
I think related to that, can your system actually monitor and control if there's other pumps that are installed that aren't Grundfos pumps or other pieces of equipment?
Yeah, absolutely. So that example I showed where we had just that small module that was monitoring the pump's conditions and a high level alarm, those weren't even our pumps. It wasn't even our panel. We were just looking at electrical signals. And that's the beauty of this system is you can monitor and manually control anything that has an electrical signal. We have a customer, excuse me, we have a customer in South Georgia that uses this system. They had a major sewage spill. They had a line breakage on their main. It was running through a very wooded area and it wasn't picked up for almost 2 days. And they spilled, they don't even know the actual volume, but it was a lot of sewage that was spilled out in the woods. But what had happened was the discharge pressure on their stations, when it drops below a certain PSI, they wanted to be notified. They said, from now on, we know if that pressure on the outside of this, on the outgoing side of the station drops, we know there's a leak somewhere because it should never go below this PSI. So they're actually using GRM just for that. So as an alarm notification, so that issue never happens again.
Got it. Yeah, that was my last question for you before we move on is, what's sort of the ideal implementation setting? What would a utility, what sort of scale setting? I mean, you just gave a rural example, but is this being adopted widespread, or what are some of the things that utilities need to know?
So most of our customers are medium sized, so they're not really big, they're not really small, but we do work with the large customers that have especially outlier stations that aren't on their existing Scada, where it might be too expensive to pull that data in, but they still want to be notified if they have a high alarm condition or a pump failure or something like that. So really we run the gamut and we do everything from groundwater to sewer to industrial applications even, where we're monitoring industrial pump stations. Great,
so appreciate that, Brendan. And I know there's a couple more questions in the chat, so maybe you can continue to dialogue there. And we're gonna move on to Ulrich Borop Hansen from APX10. He's the CEO there, and he's our next presenter.
Thank you so much. Thank you. As said, my name is Ulrich Hansen. I'm the CEO and also co-founder of the Nordic-based software company APX10. I would like to briefly share with you some of the thoughts and findings when it comes to making sewer reinvestment smarter using data and also asset management tools. Next slide, please. Our promise is that we want to help our clients make their reinvestment budgets 10 times more valuable. It's a pretty bold statement, but we believe that water utilities can do so much more with their current budgets. Next slide, please. Our upbringing is in the Nordics, but our focus is global. We are today owned by American water specialized private equity company, Cybria Capital, and also the global water pipeline leader, Alliaxis. We come out of the water utility engineering domain, and therefore we also know that it's not all about computer science. The customer success depends on our ability to actually combine our subject matter expertise with our strong software development skills. And what we do is that we offer the market an off-the-shelf asset management solution tailored for the mid-sized utility segment. We believe that this majority of the utilities are often forgotten when consultancy companies and traditional software suppliers rely on complex, also customized and resourceful setups. Instead, you are actually now in a situation where you can get a plug and play kind of solution, since technology and also general market maturity have improved over the last couple of years. And this is not just something we see as being true in the Nordics, where we hold a leading role and also large market share, but it's something that we experience when addressing American utilities. And focusing on data and asset management, we have chosen a path where we have specialized in sewer networks. Next slide, please. The core of proper asset management and our business is data. And using data the right way will actually allow water utilities to uncover massive potential for optimization. And in our terminology, we refer to this as reaching the apex, what you see in the triangle to the right here. We capture, we aggregate, and we analyze data, allowing for an optimized decision overview. It's a way to become more data-driven in the reinvestment decision process, but it's also a way to get a deeper general understanding of the sewer network and its impact for future budget planning. And using our proprietary cloud platform, combining GIS and also business intelligence and our latest generation algorithms and AI, we always use and rely on dynamic data. Data that's already present in the utilities within your GIS systems, your CMS systems, your Scada, as mentioned before, and any kind of sensor, that you might have, including the wide range of available public data in each of the markets where we operate. And for many US-based utilities, this data already exists, and it's not really used in combination and in asset management context. And that means that bringing it all together in one platform actually allows for a, you can say, new and more and deeper value to be created. Next slide, please. Our solution, the Data Apex, is not your conventional add-on used, for example, in whatever existing GIS system that you have today. It's instead a structured approach, deliberate structured approach to decision-making, which makes it easy and accessible and intuitive. And this applies both to management and specialists within new utilities. And we want to make sewer reinvestment easy and understandable, but at the same time include many more variables to the equation than previously used when taking these decisions. That's kind of tricky. But data actually now enables the water utilities to reach the apex mentioned before by combining analysis related to very specific utility problems, such as the overflow problems that we just discussed. It could be inflow and infiltration issues as well, and the hydrogen sulfide, where we are able to combine that in a more classical asset management context, which is our focus on condition assessment, where we, through likelihood of failure, uses machine learning, as well as an AI-based consequence of failure analysis, where we focus on the impact for ratepayers, for businesses, and general infrastructure. Adding all of these elements of a broader utility overview as well will allow all the assets to be capitalized with relative reinvestment costs, which we can add, and also, if available, accounting values. This will give you a thorough data quality analysis in the end, which will enable this apex to be reached, simply combining all the sets of data just mentioned before. The apex analysis then takes all these variables into consideration, although it still presents a reinvestment decision in a very, very simple view, where it identifies the individual pipes from a criticality point of view and also prioritizes and provides a full list of refurbishment needs, simply making all the complex stuff as simplified as possible. It introduces the possibility for utility and also the individuals to set a specific balance between the variables, which actually allows for multiple scenarios to be built in terms of which way to go. And ultimately, it represents a complete new utility decision paradigm where everybody can actually participate in the discussion on why is it that we focus our future and current budget as we do. Next slide, please. Implementing and using a platform like the Data Apex is actually easier than you might think. It is fast, since data is actually already present, and that's a key here. There's no need to external consultants to be involved in a project like this. And it is important to understand that it's not a matter of making asset management and data-driven decisions into a complex IT projects, but actually respect that you can start where you are at your current level with the current data that you actually have in front of you. It involves only limited internal utility resources, as the setup that we have is a matter of access to the data. Then we actually take it from there, where the data processing is done on the platform. And hence, you as a water utility should alone focus on using the value created and onboarding the organization in becoming more data-driven. This is where the real hard work lies, that you actually convert all these findings into changing the way that you operate going forward. So my comment is that you're actually already good to go as you are. As a utility, they have a lot of available and relevant data today. Unnecessary investments in new sensors and hardware is something that we believe should be avoided, as we can integrate and bridge whatever kind of data point is available today. Not meaning that sensors and hardware going forward is irrelevant, but you actually have what it takes to begin to operate with data and strategic asset management already. Next slide, please. Being data-driven and using your data for asset management brings multiple value in return. It actually allows you to spend the CapEx budget that you have where it matters the most, considering, you can say, decreasing OpEx as well. The organizational value of breaking down the historic data silos that we also find in almost any utility throughout the world. It uncovers not just new insights, but it's also a new collaborative possibility, you could say, and it creates new workflows between departments as well. Being deliberate on working with these kind of data and data in general, and also latest cloud technology as we run on, makes utilities attractive as well for next generation utility leaders. I think this is important because they will join the organizations going forward, and they will come with new and different expectations when it comes to tools and also decision-making paradigms. And of course, I would say even more importantly, the general saving potential using a platform like Data Apex is extremely important when it comes to, you can say, hands-on things like optimizing your CCTV spendings, for example, and energy cost as discussed before. But you are able to actually make your reinvestment cost and decision much more precise by targeting refurbishment in areas and also pipelines which have the biggest positive impact on failure reduction and also consequence for society, as well as you avoid refurbishment of pipes which actually have a significant longer lifespan left in them. This ultimately brings you 10 times more value from your budget when you are utilizing data at an optimized level. All right, thank you. That's
Thanks
my
so much
presentation for now.
Great, appreciate this so much. I have the same question about the appropriate kind of scale of utility installation for this. If you already have to have some data and some of your streams digitized, for example, like what are some of the baseline conditions?
I would say,
yeah,
having a you can say digitized GIS setup, that's a minimum requirement. And then you can say what we look at is that it's not necessarily 100% full spec on your GIS system. If you have some data, then you're actually good to go. And then we have some clever AI systems that can also help you define what is it that you have in your network in general if you don't have it in your GIS system. But a basic starting point is a simple GIS solution.
And there's a back-end question from the audience here about, is Esri Maps your base layer, or is there something else that's the base layer?
No, it's a you can say solution that we have developed on our own. So the entire GIS level and BI level is actually an Apex 10 thing. So we run on top of all the existing systems that you have today, but we do not have a need for you to provide some sort of, you can say, system or technology upfront.
Got it. And then I have a front-end question, which is obviously a lot of what you're monitoring would be of interest to the public, but this isn't really a public front-facing system, right? This is really designed to be for utility operators, or some aspect of this help utilities actually communicate with their customers about things in the system?
I would say it is mainly used internally in utilities, but it is used both on an operational level, but also in the C-level, actually not just to discuss refurbishment, but also up against the board meetings where they discuss the risk of not increasing or lowering budgets going forward. So it's widely used, but within the closed doors, you could say.
Great. Great, thanks so much. There's a couple other questions in the chat, so if you wouldn't mind handling those there, I would really appreciate that. And then our next presentation is actually, we had a last minute cancellation and had to go to our backup video, which is terrific. So we'll be doing a video presentation and then turning it over to Jacob Amrine to answer questions. So let's tee this up.
Hey, Matt Starnes, Product Marketing Manager for Bucher Municipal North America here. Thanks so much for having me. So Bucher Municipal, who are we and why are we here? In one word, it's really solutions. That's right, we're the world's leading supplier of municipal vehicles. And then taking a look at Bucher Municipal North America, we focus on street sweepers and sewer cleaning equipment solutions. And the sewer cleaning equipment was created and developed in Denmark. So that's the reason for the participation today. We're very proud of the technology. We feel that European technology is quite superior. And really, there's more than one type of sewer cleaner solution when we talk about these. It really comes down to your application. What do you need the machine to do efficiently and correctly? In our solutions, compact combination with recycling, and combination with recycling. So the differences there are the compact combination sewer cleaner, just at a high level, is best for narrow streets, low accessibility, and weight restrictions, as opposed to the compact combination with recycling sewer cleaner, which is best for urban areas, productivity, and saving resources. And then finally, the much larger combination with recycling sewer cleaner is best for urban and industrial applications, and you get the productivity boost and the saving of the resources as well. So looking at that compact combination sewer cleaner, the Bucher CityFlex C40 is a non-CDL, so you don't need that commercial driver's license for your operators, non-CDL vehicle. And this is really good for populated urban areas. This particular picture you're showing right now, I was out with Jacob Amrine, one of our service techs, and we were just right off a busy main street in a residential area, and we really could get in there. We could, do the work really quickly, and it's just a really good versatile machine. The compact combination with the recycling sewer cleaner, the recycler CR60, is really the best of both worlds because you get that compact combination with the recycling system. So you can work again in those urban residential areas, but the noise level is really low and you don't have to refill water or disturb traffic. Now, as I call the recycler CR120, it's the big beast. It's a souped up combination with recycling sewer cleaner, and really the best option for productivity and to save a lot of water there. And some sewer water tanker recycling benefits. As we've stated before, you don't need to fill up with potable water in order to work. And it's really almost like having a portable water treatment plant right there in your vehicle. Just going to show a couple shots here. This is the recycler and the hose going through a manhole. And then here's an under the street view, if you will. And that's sludge that the hose and the nozzle are breaking up. And then taking an inside look at our movable partition, you see on the left side there, that's our clean water. And on the right side, it looks like a drop there. That's the sludge that's incoming. So it's sucking that in here. And then you can see the partition has moved where you have less water over there that's being recycled. And then you have the sludge that you're breaking up being collected so you can later dump that into an appropriate disposal landfill. And just want to mention also our remote reel. It's the best helper for your sewer cleaning unit. It's a little accessory that can work with any kind of sewer cleaning truck, which is really great. And you can get into fields, go downstairs, up and down stairs, into parking garages, those hard to reach places. So that's another accessory we have in the sewer cleaning solution department. And finally, we want to offer you a free report. It's learn the 5 things you must know before buying a sewer cleaning truck. Completely free, offer. We touched on a few of these things, but really this free educational report can help you out. There's the link there, absolutely free. We're offering it to you today. Or just go to buchermunicipal.com, and we've got right at the top of our homepage, you can request that report. I just want to thank you for your time, and back to our host.
Thanks so much. That was a terrific overview, and just got to say how excited I was to see some big trucks and big machines. That's not always what we're talking about here on the these innovation showcases, and it was just fun to see an example of that in action. So thanks so much, Jacob, for being here to answer questions. I want to kick it off with one about the just again the setting. Where does this make the most sense? So there's this obviously great opportunity here to think about the clean water implications. Does this work best in one water systems, or you know, who's the kind of natural target audience or user for this?
Well, we're targeting all municipalities along with contractors. So what's nice with our 3 size units is we can go from a small municipality all the way up to a larger municipality, a larger city, or contractor that's handling most of that work for the city. What's also a good benefit to our small C40 is that it is a non-CDL, like Matt had mentioned in the presentation. So you don't need to narrow down certain operators that can or can't use this machine. It's pretty versatile. Anybody can use it. And then just basically the tighter areas that you need to get into, you'll take a step up to one of the bigger trucks. If you want to conserve water, that's where you're getting into the recyclers. And then we have 2 sizes, one for the smaller application and then one for the much larger.
Great. And then there's an audience question about the difference between recycler and non-recycler sewer cleaning trucks.
So the non-recycler sewer cleaning trucks, or most market competitors, everybody makes a non-recycler sewer cleaning truck. It's one that requires constant feed, either a constant feed of water or multiple trips back and forth to the hydrant, causing you to put more clean water back into the sewer system. And it honestly can be a pain after a while. When you get into the recycler, what you're doing is we're actually starting the day with a fresh load of water like you would on a regular combination unit. And we're continuously using that water to work throughout the day. So instead of constantly pushing clean, fresh water back into the sewer and contaminating it, we're using the water that's already in the sewer system to clean the entire system as you're working throughout the day.
Great. And you know what the average savings are?
It kind of varies. We had a customer up in Canada that did a report, and they saved about 2.5 million gallons over the course of a contract. Wow. Just that was an 8 month contract that they used, and they saved that much water just by using the recycler.
Yeah, so critical part of meeting kind of our overall climate sustainability goals for municipalities. So
absolutely.
Thanks so much. Really appreciate it.
Thank you.
Your questions. I think there's a few more in the chat, so if you could answer those there.
Yeah, sure thing.
Great. We're gonna wrap it up with our final presenter, Soren Rasmussen from Landia. So Soren, bring us home.
Yeah, thank you, and thanks to those of you who are still hanging around here. So we've heard a lot about some pretty high tech and very nice solutions. I'm going to take it down a little bit on the more practical level here and down into the actual soup, so to speak. Talking a little bit about chopper pumps for lift stations. Next slide, please. So as many of you are probably aware, and Elena, you had introduced with a little article from Los Angeles there, where they had some issues just recently. This is a pretty common phenomenon, right, around the world, in that sewage is really no longer just sewage. We're all well familiar with the very large amounts of flushable wipes and grease and plastics and all the nasty stuff that goes into sewers, and at best will build up a scum layer, or in worst case can be massive fatworks. Next slide, please. And this has obviously not gotten any less here in the COVID times, with increased use of sanitary wipes and face masks, etc. So those of you who are in the wastewater industry, which I'm sure is probably a lot of us, You're familiar with these pictures of how things can really just clog up the pumps. Also creating, well, not alone creating headaches and very expensive repairs, but also odors. Lou, you mentioned it from Chicago, where some of the sewage stations can, build up a lot of hydrogen sulfide and stink up the neighborhood. Next slide, please. So what Landia's approach to that is, it's really fairly simple. We have a heavy-duty chopper pump, which, as many people may not know, Landia actually invented the chopper pump some 70 years ago. So it's been around for a long time. But here in recent years, we've seen a bigger need for it in the sewage collection system. So we came out with our Gator series, which is the image you should see there on the screen is a chopper pump, submersible chopper pump. It's equipped with a Venturi nozzle that when we pump sewage through it, it creates a vacuum, and then we have an air pipe or an air hose that can pull air down from the just from the atmosphere. It doesn't need a compressor or any other air source. It aspirates the air down. The chopper pump you see on the left there has a hardened steel knife system that basically just chews up all the solids that are in the wastewater, the wipes, the rags, and so forth. Then we take this irrigator, we basically just dump it into the sewage wet well, and it sits there and it just recirculates, chews up all the debris, recirculates the wastewater, injects fresh air, and effectively just cleans out the station, and also keeping it odor free. Next slide, please. So this is a little video that shows that irrigator in action. As you can see there, this particular station had quite a scum layer. It took a little while to get the pump through.
Is the foaming the biological activity you're talking about?
Yeah. Yes, exactly. There was a lot of built up biomass in this station.
Yep.
But as you can see in this image here, now it's a perfectly clean lift station. Yep. And once we get to that point, you really only have to run it a few minutes a day to keep it at that stage. So we're not dumping any chemicals in. We're not pumping any, we don't need Booker to come out and clean out the station per se. We just chew everything up and keep it recirculated within the station while keeping it fresh. And these Gator units, they are available for rent. And we keep them in North Carolina at our facility there. So if you have a very nasty lift station, we're happy to send you one of these. You can, test it out, see how it works for you. Note that this is not for every single lift station out there, right? We see the sewage pumps clogging. Mass mentioned how some of that can be, prevented with a VFD or reverse action. Grunfos has some solutions to try to prevent this stuff. But even with all that, there are some stations that are just so nasty and have so much debris in there that you really need a heavy-duty chopper pump to handle it. And so and it may be 10% or so of all the lift stations out there that are that bad. And that's kind of where we come in with the in situations where regular sewage pumps cannot handle the sewage is typically where we come in. So the Gator series is a standalone unit. It's a drop-in unit. We don't replace the existing sewage pumps necessarily. In most cases, after we've macerated all the debris and gotten it all mixed up, the sewage pumps can typically handle what is fed to them. The problem is if it builds up too much, and then gets pumped down, that's where you get the big mats of debris, and that's where the sewage pumps start clogging. So we can a lot of times prevent that. Next slide, please. That's really all I had for this brief introduction. If you're interested in trying it out, give us a call or send an email.
Thanks so much, Soren. I appreciate that. Do you also help your clients and utilities kind of decide which of the stations make the most sense for the fit? I mean, are you able to do that sort of evaluation, or is that something they need to bring in advance for selection?
We can, but I'll tell you, they usually know.
Yeah.
Every city has
their problems.
One trouble lift station that's just worse than all the others.
Yeah.
Some of them have 3 or 4 or 8 of them, but there's usually one that's really the nasty one, and that's where they want to demonstrate our equipment to really get a feel for what it does.
Got it.
On our website, there's also additional videos and information on this Gator series chopper pump.
Great. I'm going to ask George to launch a quick audience poll and then ask one more question to wrap it up, which is a specific audience question about how fine are the pieces that the chopper is able to put your debris in, and can the screens still catch it at that point, or is it finer, so fine it's going to go through? Yeah.
No, so it's basically, there's no real hard number, right? You can get, 1/4 inch, 1 inch, whatever pieces. It's mainly what we do is break up the big mats of debris that's conjoined with the grease in the lift station. We do, of course, reduce the particle size, but it's not so fine that it won't get caught in the screens at the headworks.
Yep.
Unless you only have a 1 inch bar screen, then you have some other problems.
Sure. Well, we really covered the waterfront here from the very digital to the extremely physical in this presentation. So I just appreciate all the presenters. Thank you for sharing what you are doing to try to prevent some of the major challenges that we talked about at the upfront. I mean, this is so timely and topical. I mean, we're all trying to figure out how to keep these major overflows and sewage events from affecting our water quality. So thank you all for everything that you're doing on that. I'm just going to wrap it up really quickly. George, if you'd move to the next slide, we do have several more events coming up, including in this series. Our next is our Third Coast Water Seminar, which is a research-focused convening, and it's on a really exciting topic this month, Smarter Cities and the Energy Water Nexus. So lots more to come. Please register. The QR code that's on your screen will take you to our events page where you'll be able to register for these and many other events. And then we also have August's Third Coast Water Seminar coming up on hydrologic performance of the NPCC Green Roof. So another really interesting green infrastructure conversation in Third Coast. Next slide, George. We also want to preview Chicago Water Week 2021, which is coming up October 11th through 15th. So still in summer, but thinking a lot about this fall programming. And in Chicago, we're really excited this year. It will be leading us right into Vfds, a very large wastewater convening that takes place here in Chicago. So please make sure you're signed up for that and taking a look for current events, both during Water Week and during Vfds. We're really excited to be back, part virtual and part in person this fall. And finally, if you'd like to pitch us on an event, share information, talk about your critical water challenge that you're facing, and want to find ways for Current to help, please reach out to us. We'd love to collaborate with you. This partnership we have with a Trade Council of Denmark has emerged from conversations just like this one. So we really look forward to working with many of you to think about what else we can do to help solve water together and really meet these rising water challenges that we have. So thanks to all of our presenters again. Have a great rest of the day, and we'll see you next time.